This video looks at the three types of Peco turnouts: the Insulfrog, the Electrofrog, and the Unifrog, and the advantages and disadvantages of each types, and any tips and use for modifying, for using them, for wiring them on your model railroad layout. We're going to look here at the Insulfrog with the insulated frog turnouts, the Electrofrog, and the relatively newer Unifrog. First type is the Insulfrog. These are designated, and there's one right here in front of the camera, right here, and I'll show another one right close here. You can tell these ones have a plastic frog, and so these are, you can drop these into your layout without any extra gaps or insulated rail joiners. They just fit. They can fit right in, and they are ready to use at any one time. There's really one, the major disadvantage, and this one's not too bad since it's a short radius switch, is that the frog here is plastic. So if you happen to have a lot of times switchers and short wheelbase steam locomotives, you potentially could get a stall at this point. The other point here is that sometimes the black plastic, even though this rail here is actually painted, the black plastic frog is a bit more obvious, versus something like the metal frogs. These painted rail here, this visually looks a lot better than just a plastic frog. These are similar to like an Atlas Snaptrack switch. Anything with switches with plastic frogs, this particular type is also applicable too. The second type is the Electrofrog, and that's what this crossover here is made out of. And here's a close-up here of an Electrofrog turnout. You can see that you have an all metal frog. All the rails are metal all the way through. And these generally, while these have the best look and potentially the best electrical conductivity, they really cannot be used on a layout straight as is. They really require some either modifications or to some very least insulated rail joiners to use them without creating extra difficulties. Now is actually the appropriate thing is to look at closely at a Electrofrog switch. So at the very least, you're going to have to add an insulated rail joiners here at the frog end. So as an example, like this turnout here, you can see there's a pair of insulated rail joiners here at the frog. These will need to be added at a minimum. This will prevent downstream shorting and power problems with things of opposite polarity. One thing is that with an unmodified Electrofrog switch, there's also an issue that you may hear this term DCC friendly or not. This turnout as is, Electrofrog, is not technically DCC friendly. The issue with DCC friendly turnouts is the potential of you could have a different polarity between this this particular point rail here and the adjacent stock rail. And you can see how this can happen. If we call this outside rail positive and this rail is negative, the positive rail goes all the way through as you'd expect. But the negative rail, the opposite rail, because this point rail is touching it, all of the metal in here, the rails in here, are all the same polarity. So this includes this particular, point rail, closure rail, the frog, including its wing rails, these particular, leaving the rails that are leaving here, this closure rail, and this point rail. So you can see that you could have a negative decharged point rail right against this positive stock rail. If you have, locomotives with potentially wider wheels, or just have maybe they or as they move down the track, it is possible that you could get a bridge between the rail, these two rails. What will happen then, that will cause a short. If you're using DCC, your command station will probably beep at you, and it may literally cause everything on your railroad or this particular power district to come to a halt. So we want to prevent this. We need to have these two adjacent rails and these two adjacent rails being the same polarity at the same time. And so what we need to do this, we need to completely isolate the frog. So here, this can be done here by actually cutting a set of gaps here in the frog rails here. We already got the insulated joiners here. By doing this, this will isolate the whole frog completely and will prevent this stuff, this rail this here from shorting out this side. And in addition, what you also want to do is to maintain electric conductivity and to not rely on point rail contact, is to create a jumper between the stock rail and the adjacent closure rail. So create a jumper between this rail and this rail. And here's an example here of a turnout that I have done before, where I've added actually gaps here, and then underneath I had basically took out some of the plastic here and put a short wire piece and soldered across the bottom side here of both rails. This will ensure that will allow that power. We can quickly get the stock rail to these closure rails and point rails. I've also done with some of these turnouts, I've actually physically soldered across the hinge. That way this is basically ends up being one continuous piece. Some turnouts, like HO turnouts, there may just be one piece of rail already, which saves you an electrical problem here at the hinge. You can see that, especially like here, here's quite a distance now between these insulated gaps in here, which will require that you power the frog. And so, and by this will require you to solder a rail, a wire to the frog assembly somewhere here, and then this wire here will needs to go to either a switch machine, auxiliary contacts under here, a micro switch of some sort, or potentially a frog juicer, such as the Tam Valley Hex frog juicer. This will allow that the point polarity here will switch automatically according to how the position of the switch is. Little tip here: these gaps in here. Usually, I usually cut this with the Dremel type tool. One advantage here, if you save an old year, this tool here is actually, the cutoff wheel here has actually been worn down a lot. Advantage of this, especially with N scale, is you can do this. You can worn off cutoff wheel is small enough diameter, we can get in here without potentially nicking the rails too much. Then, as I found another use here, a tip, say, is that these bread tags, they're on a lot of bread, bagels, things like that. The plastic of this, the thickness of this is exactly the same width as of the Dremel motor tool cutoff disc. So here you can cut strips of this plastic using a sharp X-Acto knife, put it into the holes, into the gaps here, use some CA to glue it in place, and then later carve away everything that does not fit the rail profile with this, and this will create a nice gap that cannot be, you don't have to worry about it accidentally the rails actually growing together over time. It was unlike to do with these switch, but it keeps a nice continuous gap here without any potentially nice smooth surface. Here you can see that I have actually added these plastic pieces. They're in orange here. This is not yet. This has been glued in place here, but not yet reduced. And so we can just take our blade here and shave down anything that does not match in with the rail profile. As an example. And it's very important to do so. As most important is on the surface that's where the flanges are and the like. And then you can also then go over with the file and to take care of anything that's hanging over the top. And you can put your fingers and making sure that you have a nice smooth surface like that. Another good thing to always to test is to use a multimeter, especially when cutting gaps and switches. You do want to make sure that your switch here actually is not live anymore across the gap. So if I have touched one probe here and one probe to here, you should note that there should be no movement on the ohm meter. This means infinite ohms. Versus if I touch these two rails together, note the needle goes all the way over to 0 because that means you have continuity, and then you basically would have a two rails are connected together. There could be an indication of a short if you expected not to see that, but you should expect to see no movement across these to come up with to make sure that it's dead going across. Now the third type is the Unifrog, and this is relatively new turnout from Peco, released in the last 2-3 years or so. It will eventually supposedly replace all of the Insulfrogs and Electrofrogs in line, so it only has one turnout. It's not avoiding all these different all these particularly different types. It is really the best of both worlds. As it stands, as the Insulfrog stands, it actually, if you note, you can see that you have an isolated frog in here that's all metal rails. So this is actually dead in here. You could use this as is in your layout without any insulated rail joiners, and it would work as one of the Insulfrogs. You can also then, if you wanted to, you could also use this wire here, and the wire around here is a frog wire. That's wire that's soldered to the frog already. Basically, it is what equivalent to what I did here earlier with this frog wire here. It already has the wire soldered already. Then you could actually again power this frog here through a hex juicer, a micro switch, or switch machine contacts. You also notice on the back side here, there's those stock rail closure rail jumpers are already here. Again, equivalently what we did here. So this switch here is a DCC friendly turnout. It already has all the modifications, all the gaps, all of the jumpers already added in here, so you don't necessarily have to add any more to here. And because this is gapped already here, right, leaving the frog, like here, these switches can be installed in your layout with all metal rail joiners. You don't need any insulated rail joiners on any of the and you don't on these ends or anywhere else for that matter, unless you're actually creating a block gap and you're not running DCC operation. Here in this turnout here is not power routing. All legs are live at all the time, so we don't have to worry about any potential dead spots. So it's hoped that this video will help kind of show the three major types between the Insulfrog, the Electrofrog, and the newer Unifrog type switches. If you're doing this in N scale right now, the Unifrog is only available in number 6, and hopefully it is generally intended to replace the other lines in which there are more varieties of these available in HO. In conclusion, if you have an Insulfrog like here, you can use these as is. There's not an issue. Electrofrogs will require at a minimum insulated rail joiners, to the potentially of adding extra gaps and extra feeders to improve connectivity. If you have a lot of application for these, like an N scale here, number 6s, you can use these again straight as is, or you can choose as you want to power the frogs through external contacts.